All right, welcome back. So I think I'm going to continue on with Hugging Face. So what are tools? So we already completed step one to understand what are agents. Agents are LLMs that can function on their own, interacting with the environment and using tools. So so agent. Oh, this is what our LLMs. Oh, here we go. So what is an agent here? We'll explain it very clearly. So an agent is an AI model capable of reasoning, planning, and interacting with its environment. We also learned what are LLMs and messages systems. So we learned about that in the last one. So LLMs are large language models. The word large is quite ambiguous. They can be very, very large, where you can only run it in like a data center environment, or they can be quite small, where you can run it just on your laptop. So the large really doesn't define an actual magnitude. But even the smallest one is large in comparison to uh, non-LLM technologies. So they have a lot of parameters. They have um, a lot of things that can be trained. So what is a large language model? Uh, put simply, it's a type of AI model that excels at understanding and generating human language. So that's what the second L stands for, is language model. Um, all right, and then the messages system. Um, what's a message system? So they define how the models should behave. They serve as persistent instructions, guiding every subsequent interaction. So as you prompt an AI, you actually are giving it uh, so if I prompted the number one like that, it's going to respond reason for a couple seconds, and then it's going to say, I noticed you type one. Then if I prompt it two, now I didn't just prompt it two here. What I did was I prompted it one, I prompted it this here, and then I prompted it two. So I basically did that in a data structure that kind of looks like this, and it all happens behind the scenes. We can see the UI takes care of it, and it it'd be really cool if it could just start saying like 4, 5, 6. Like if I typed in 4 here, now it could just say 5, and it could start playing this game with me where we're just typing numbers. See, that would be to me like really impressive, but we can see it's not catching on to what I'm doing, and kind of, like if I did this with a human, I feel like there'd be a point where the human would like type back 7. I know that's what I would do if someone just kept randomly, typing 1, 2, 3, 4, 5, 6 one at a time. Eventually, I would probably just as a joke type in the next number, and we can see, it's not doing that. So. But the point I'm trying to make here is, even though the UI makes this look nice and clean, like I'm sending it the number 10, um, I'm actually sending it everything I've sent it before, including the outputs that it sent to me. So if we look into the reasoning, we can say the user typed consecutive numbers 1 through 10. So you can see, yes, in fact, that output does contain what I wrote prior. All right, so now we're going to move on to studying tools and actions. One crucial aspect of AI agents is their ability to take actions. As we saw, Sorry about that. As we saw, this happens through the use of tools. In this section, we'll learn what tools are, how to design them effectively, and how to integrate them into your agent via the message system. By giving your agent the right tools and clearly describing how those tools work, you can dramatically increase what your AI can accomplish. Let's dive in. What are tools? A tool is a function given to an LLM. This function should fulfill a clear objective. Here are some commonly used tools in AI agents. Web search allows the agent to fetch up-to-date information from the internet. Image generation creates images based on text descriptions. Retrieval retrieves information from an external source. API interface interacts with an external API, GitHub, YouTube, Spotify, etc. Those are only examples. You can, in fact, create a tool for any use case. A good tool should be something that complements the power of an LLM. For instance, if you need to perform arithmetic, giving a calculator tool to your LLM will provide better results than relying on the native capabilities of the model. Furthermore, LLMs predict the completion of a prompt based on their training data, which means that their internal knowledge only includes events prior to their training. Therefore, your model needs up-to-date data. Therefore, if your agent needs up-to-date data and not your model, because you can't modify your model except through like fine tuning. But if your agent needs up-to-date data, you must provide it through some tool. For instance, if you ask an LLM directly without a search tool for today's weather, the LLM will potentially hallucinate random weather. So what's the current weather in Paris? Um, Sunny, 30 degrees. LLM hallucinates. 10 degrees rain. Agent has a web search tool. A tool should contain a textual description of what the function does, um, a callable, something to perform an action, arguments with typings, and optional outputs with typings. And then the other thing that's pretty cool about tools as well is if you intelligently design your tools, you might be able to get better outcomes than commercial products like ChatGPT. Because if the agent is just using web search to go out and look at what the weather is, it could get the weather very wrong, right? So like now if it gets like a weather thing like this, that's good. But a lot of what you see on the internet sometimes, so if I do a toolkit like that, or let's do Eiffel Tower. All right, it's not doing it now, but a lot of times you get an AI generated explanation that it's AI reading from AI, and it's not foolproof that it searches the web. So instead of having it just search the web, you could give it like a weather.com API, or just limit it to searching weather.com. All right, so how do tools work? LLMs, as we saw, can only receive text inputs and generate text outputs. They have no way to call tools on their own. What we mean when we talk about providing tools to an agent is that we teach the LLM about the existence of tools and ask the model to generate text that will invoke tools when it needs to. For example, if we provide a tool to check the weather at a location from the internet and then ask the LLM about the weather in Paris, the LLM will recognize that question as a relevant opportunity to use the weather tool we taught it about. The LLM will generate text in the form of code to invoke that tool. It is the responsibility of the agent to parse the LLM's output, recognize that a tool call is required, and invoke the tool on the LLM's behalf. The output from the tool will then be sent back to the LLM, which will compose its final response for the user. The output from the tool call is another type of message in the conversation. Tool calling steps are typically not shown to the user. The agent retrieves the conversation, calls the tools, gets the outputs, adds them as new conversation message, and sends the updated conversation to the LLM again. From the user's point of view, it's like the LLM had used the tool, but in fact, it was our application code, the agent, who did it, not the LLM. We'll talk a lot more about this process in future sessions. How do we give tools to an LLM? The complete answer may seem overwhelming, but we essentially use the system prompt to provide textual descriptions of tools available to the model. So, system message, you are an AI assistant designed to help users efficiently and accurately. Your primary goal is to provide helpful, precise, and clear responses. You have access to the following tools. Okay. For this to work, we have to be very precise and accurate about what the tool does, what exact inputs it expects. This is the reason why tool descriptions are usually provided using expressive but precise structures such as computer languages or JSON. It is not necessary to do that. Any precise and coherent framework would work. If this seems too theoretical, let's understand it through a concrete example. We will implement a simplified calculator tool that will just multiply two integers. This could be our Python implementation. All right, so def calculator multiply two, there we go. Calculator which returns a int, so we can do the dot toString method on an int data type. So our tool is called calculator. It multiplies two integers and it requires the following inputs: A int an integer, B int an integer. The output of the tool is another integer number that we can describe like this: int the product of A and B. All these tools are important. Let's put them together in a text string that describes our tool for the LLM to understand. All right, so here's the text string. So tool name, calculator, description, multiply two integers, arguments A colon int B, so this is type setting, um, and then outputs an integer. Reminder, this textual description is what we want the LLM to know about the tool. When we pass the previous string as part of the input to the LLM, the model will recognize it as a tool, and we know what it needs to pass as inputs and what to expect from the output. If we want to provide additional tools, we must be consistent and always use the same format. This process can be fragile and we might accidentally overlook some details. Is there a better way? Auto-formatting tool sections. Our tool was written in Python and the implementation already provides everything we need. A descriptive name of what the tool does, calculator, a longer description followed by the function's docstring comment, multiply two integers, the inputs and their type. The function clearly expects two ints, the type of output. There's a reason people use programming languages. They are expressive, concise, and precise. We could provide the Python source code as the specification of the tool for the LLM, but the way the tool is implemented does not matter. All that matters is its name, what it does, the outputs it expects, and the output it provides. We will leverage Python's introspection features to leverage the source code and build a tool description automatically for us. All we need is that the tool implementation uses type hints, doc strings, and sensible function names. We will write some code to extract the relevant portions from the source code. After we are done, we'll only need to use a Python decorator to indicate that the calculator function is a tool. So, okay, so now we know that this is a tool, so our agent can use it as such. So hopefully it will go into this code uh, next. And a decorator is simply a function that takes a function um, as input. So the tool function takes this calculator function as input. Hopefully we'll see later uh, the tool function. Note the tool decorator before the function definition. Yeah, so right here. With the implementation we'll see next, we'll be able to retrieve the following text automatically from the source code. Tool name, calculator, description, multiply two integers, arguments a colon int, b colon int, outputs int. As you can see, it's the same thing we wrote manually before. Isn't that cool? Yeah, that's cool. I'll follow along with that. Generic tool implementation. We create a generic tool class that we can reuse whenever we need to use a tool. Yeah, so it doesn't have to be a function. It can also be a class. Yeah. Disclaimer, this example implementation is fictional, but closely resembles real implementations in most libraries. So, yeah, so you would create a class tool, class representing a reusable piece of code, a tool, attributes, name string, name of the tool, description string, a textual description of what the tool does, function callable, this function, the function this tool wraps, uh, arguments list, a list of arguments, outputs, string a list, return. Okay. So def init, self dot, all of these attributes, name, description, func, arguments, and then you set the type of that. Um, okay. All right. Dot name equals on name. Okay. Yeah, so these are set here. So there you go. Representation tool. Okay, yeah. So here's that template, right? So like the arg name, arg type for yep. So we've got a for loop here. There we go. Yeah. So let me put that into action. Okay, perfect. So now I got that tool class, and now I can even go ahead and do this now because it can be used as a decorator. Oh, you know what? No, it can't. See, that's what I thought. I thought you had to. I thought it. Oh, well, let's keep going. Maybe we'll figure out later. It may seem complicated, but we'll go slowly uh, through it. We can see what it does. But if we go slow through it, we can see what it does. We define a tool class that includes a name, name of the tool, description, a brief description of what the tool does, the function the tool executes, arguments, the expected input parameters, outputs, the expected outputs of the tool, dunder method call, name call, calls the function when the tool instance is invoked, and then toString converts the tool's attributes into a textual representation. We could create a tool with this class, oh, using code like this. Okay. All right, let's do that. Uh, oh, was something not in oh, I didn't define the. but it doesn't have yeah. Oh, right. And notice how it doesn't have toString. That's because that's a property of the decorator. That class tool does have toString. We can see we defined it right here. All right, so we could create a tool with this class using code like this. All right, let's do that. So we gotta define this function. Oops. There we go. Now we can create this. There we go. Now that goes through. Okay, so you could do that, but we can also use Python's inspect module to retrieve all the information for us. So instead of typing this out manually and creating the tool, so now we have calculator tool here, but we had to type that all that in very laboriously and manually. Um, so I forget how you can. It's like let's see here. All right, so we can do it automatically. This is what at tool decorator does. So if you are interested, you can disclose the following section to look at the decorator implementation. Yeah, so you have to have it's not enough just to have the class. A decorator is actual an actual function that calls a function. It's not it can't be a class. It has to be DEF space. So here's the DEF space code for the decorator. And my mouse is not working, which is really frustrating, but here we go. Okay, so now we can redefine the this as being part of the decorator. There we go. Inspect is not defined. Okay, maybe I need to import it. Ah, there. See? Now we got the yeah, now we got it. Just to reiterate, with this decorator, we can play in place, we can implement our tool like this. And we can use the tool's toString method that we wrote in the class. Um, oh, I'm not sure where that came from. Let me try this. My mouse not working is really frustrating me. Um, so let me do 9 space. Let me do help on it. I'm just curious where the toString came from. Oh man, I'm having trouble. My mouse isn't working. I'm very nasally congested, and the computer keeps beeping at me. This is like the trifecta of annoyance. Yeah, my mouse just randomly quits out on me. I probably need to change the battery on it. Yeah, this is too annoying. I can't do this. So from bytes to bytes. Yeah, there's no toString in here, so I think it does come from the class. I'm just not sure where the class comes into play. I think the class was called in the decorator function. So let's take a look at that code more closely. Yeah, so we can see return tool there. We can see, yeah, sure enough, it is part of the class. Yeah. So sure enough, it is utilizing the class. So there's where it calls the class, and then name all of that. It gets defined. Perfect. Perfect. Excellent. Okay, so there we go. So we can use the tools to string method to automatically, if my mouse will work, which it's not, which is really frustrating me to no end. Um, okay, yeah, I'm not sure what to do with my mouse misbehaving this badly. I guess I'll either replace the battery in it or switch to a wired mouse. I think I'll try replacing the battery. All right, yeah, that was the problem. Cool. Okay, and we can use the tools toString method to automatically retrieve a text suitable to be used as a tool description for an LLM. The description is injected in the system prompt, taking the example with which we started this section. Here is how it would look like after replacing the tools description. So there we go. You are an AI assistant, system message. And there we go. It includes everything it needs to know about the tools it has access to automatically. You don't have to do anything like what we saw here, way up here. I forget where that was. Here. So you don't have to do anything like that for the. So you don't have to call out these values specifically because you could include this sort of code here in the decorator code. So we can see it's doing the same thing, but except it's pulling these automatically. So the name comes from the name equals so uh, so name equals name. So where does name come from? Here we go. So it comes from func dot underscore name. So we can see in the yeah. Right. So a decorator is a function that takes a function. Um, so the function that we feed it dot underscore name. Um, so we're going to feed it the calculator function. So this name here is what is taken. Perfect. All right, and then description, same thing. So you got to make sure that you're uh, giving your functions, useful names, useful descriptions, all of that. When you define your functions, you need to be, um, not getting lazy with the uh, descriptions and names, because otherwise your agents won't understand what they are for. So you have to write your functions out as thinking it about them from the perspective of your agents. All right, so in the actions section, we will learn more about how an agent can call this tool we just created. Tools play a crucial role in enhancing the capabilities of AI agents. To summarize, we learned what tools are, functions that give LLMs extra capabilities, such as performing calculations or accessing external data, how to define a tool by providing a clear textual description, inputs, outputs, and a callable function, why tools are essential. They enable agents to overcome the limitations of static model training, handle real-time tasks, and perform specialized actions. Now we can move on to the agent workflow, where you'll see how an agent observes, thinks, and acts. This brings together everything we've covered so far and sets the stage for creating your own fully functional agent. But first, it's time for a short quiz. So I am going to do this on, this is just an ungraded quiz, public on there, on this here. So I am going to give away the answers here and show my thought processes going through that. When it comes to like a official quiz for certification, or if there was some sort of notice not to do that, I'd be pausing and doing it, or doing it not as part of making a video. But here, I'll just include this as part of this content for this video. So, quick self-graded, ungraded quiz. What another quiz? We know, but this short ungraded quiz is here to help reinforce key concepts you've just learned. So, active recall is a really important tool for learning. So, quizzes are a part of active recall. This quiz covers large language models, LLMs, message systems, and tools, essential components for understanding and building AI agents. Question one, which of the following best describes an AI tool? Okay, so let me think about that. All right, I'm going to go with that. And we can get the answers as we do them. Perfect, so I got that one right. Question two, how do AI agents use tools as a form of acting in an environment? Okay. All right, I'm going to go with this one. All right. What is a large language model? So these are pretty easy quizzes. Question four, which of the following best describes the role of special tokens in LLMs? Okay, and remember, the key takeaway from this is your your particular LLM that you're using will have its own special tokens. They're not standardized at all across LLMs. So Hugging Face is the place to be online, because look at this. We have a model formatting visualizer. So you can experiment with the following space, and you can actually pick out the models, and you can make a for you can see what these special characters look like, and they're going to look different for each model. So this tool here is absolutely critical if you're going to play around with agents or anything like this. Make sure you have this tool bookmarked here, because you're going to have to come back to it a lot. All right, so question five: how do AI chat models process user messages internally? Okay, yep, yeah. So they keep an ongoing a record of all the messages so far, and each prompt contains every message, because every prompt you give it is basically a fresh new thing. So if I were to uh, give it one word in one sentence at a time, without that ability to hold on to the prior prompts, it could not piece together um, anything beyond that one word at a time. It wouldn't know that eventually, after a few prompts, I gave it a full sentence. All right, so I got them all right. So next is to dive into the complete agent flow and start building my first agent. Exciting. So I finished step three, studying tools and actions. So this next one would be to learn the agent workflow. And with that, I think I'm going to yeah, this is just a short one. That's okay. Let's use Operator to build some flashcards. So uh, make me some make me high quality Anki flashcards based on the following material. All right, and then we'll get that put in, just stored away. So we've got Agent's Course flashcards. Uh, so we'll just save the output here. Oh, and you know what? I think I gave it the wrong. Yeah, I was supposed to give it for this one, but that's okay. We can. Uh, I mean, that would be the way to do it, is to do the flashcards before you read it, and then reinforce what you've already started to memorize. Oh, that would be really cool if it could actually create an online deck. Oh, that would be so cool. And then all I have to do is pull down the deck. Oh man. Yes, please. This is awesome. Oh, this is so cool. Oh, let me, I'll pause it and verify. All right, I'm back. So I did check my email, so I'm gonna see if that's been accepted. All right, so now I'll finish up and say logged into Anki Web. Oh, isn't this cool? It's actually making the. Wow, this is amazing. I am so shocked by this. Yeah, proceed with the name. Wow. Look at that. Now it's adding the cards. Absolutely unbelievable. Look at that. Now it's adding the cards. Wow. So now all I got to do is on my phone or on my workstation, I just go man, I just pull it down. I just pull it down and then I actually do it. Like I don't have to make the cards anymore. Which I mean making the cards can be part of the process, but yes. Cool. So now it should just, yeah, now it just goes. It doesn't ask me. Yeah. Wow. Isn't this cool? This is absurd. Look at that. Like you don't even need to use the Python anymore. There we go. It added 10 cards to it. Now it's verifying. Yeah, it verified that it looks good. Cool, it's done. It should ask me next what it wants to do. Oh yeah, it's sharing it now. Cool. Well, the copyright thing, I don't know. I mean, you don't need to share it, right? Private, no need to share it. I mean, if I can pull it down, then I'll just close the tab. Look at this. Oh man. Look, see it pulled it down. So now all I have to do is what is the thought action observation cycle? I don't know. A process where the agent thinks, acts, and observes, reviews the outcome. So this cycle, yeah. So it's a repeating cycle where the agent reasons, performs an action using tools, and reviews the outcome. What is the role of thought? Oh, these are kind of bad cards. Role of action. Uh, yeah, these are not good cards. Oh, this is a good one. Dynamic adaptation is the action cycle. Okay. Uh, yeah, these are not good cards. I did not like those cards. But anyway, okay, so that's gonna be it. Next video will be step 4, learning the agent workflow.